Hello, esteemed participants of the DigiTech’24 conference. Are you ready to discuss the future of exploration, drilling, and blasting technologies? As part of our session, we would like to invite you to participate in a short survey to help us better understand your perspectives and experiences in this field. The survey should take no more than 5 minutes to complete. Please scan the QR code to open the questions. Your insights will help us to better understand trends which drive technology, improve the safety of operations, and help to innovate exploration, drilling, and blasting at Kazakhstan's mine sites. What are you most excited about? Let's transform exploration together. Your participation is completely voluntary and your responses will be kept confidential. Thank you.
Всем добрый день. Благодарю тех, кто посетил нашу сессию. Постараемся укладываться в регламент, который задан организаторами 15 минут на каждое выступление.
So we give 15 minutes for each of the speaker, but first let me say a couple of words. The modern technologies and data analysis, first of all, as well as the interpretation, then machine learning and artificial intelligence. This is the most acute topic, the updated topic, and relevant topic. However, we need to understand that in one area, this is just a hype that will not bring to anything. However, in our industry, in geological exploration and mining, I'm sure, will see lots of benefits connected with the machine learning and artificial intelligence. So right now, at all of the international exhibitions and conferences, lots of equipment are demonstrated and lots of systems are being exhibited, and they help us to do the analysis of different geological results, and when we do different geoscience and geophysical experiments. So now, let me give the floor to James Edwards, our first speaker. He is a director from Sequent company.
I'll start off by a quick thank you to the opportunity that you've given me to speak here today on behalf of Sequent and I believe on behalf of the geoscience industry as well when it comes to data. My name is James Edwards. I am the mining director for EMEA at Sequent, and at Sequent we provide software solutions for geoscience data and analysis. My current role involves working with our customers to uncover insights from their geoscience data, which is designed to enable them to make better decisions around their projects and their businesses. To kick off on today's presentation, I've put 3 numbers up here on the board, and I guess the question or the ask to you is, do you recognize the numbers and can you make the link between the 3? So, to your left, the first one is the $46 trillion of value that has been identified as in situ resources by the Kazakhstan government reports. In an effort to unlock these resources, the government plans on conducting 400,000 square kilometers of geological and geophysical surveys, which is equivalent roughly in size to Uzbekistan. And beyond that, they also plan on increasing production by 40% by 2029. Now, if you're not convinced already in the value of geoscience data, my role and this presentation is to try and take you through where geoscience data fits in and the fundamental nature of geoscience data to being able to unlock this value and reach these targets. So I'll spend a couple of slides taking you through some of the examples where geoscience data fits, use some examples from industry currently, and then talk to how we can approach the availability of historical data and pre-competitive data. Now, data, as opposed to other items like labor and machinery, is a fairly unique industrial input. So many people can use the same data simultaneously without it ever being depleted. And this means the value of that data can accumulate over time, with many firms and researchers constantly innovating and generating new knowledge. So as a result of this, the value of data compounds, and it boosts productivity and it boosts growth over the long term. Governments in this have a key role to play, though, in ensuring that that data that is made available and is usable and is accessible. And the benefits between the government role industry role and research work together around the data to unlock a number of benefits. So with access to great data, reliable data, you reduce exploration risk. With reduction in risk, it allows investment to be targeted on projects and targets that have the most potential to become the next mines within Kazakhstan. So with more success, you attract more exploration investment, which accelerates resource discovery. And ultimately, in the long term, you'll start to see how that boosts the competitiveness of Kazakhstan as a mining jurisdiction. And as I talked to, the long-term benefits of the geoscience data supporting long-term economic prospectivity. At Sequent, what we do is really based all around data. Every year we run a global survey that looks at the changes and the trends in how geoscience data is managed. If you're interested, the QR code will take you to the last report we ran in 2023. And I bring this in because there's a few interesting takeaways that you can take from the report. Considering how critical data is to what we do and what the mining industry is trying to achieve, nearly 1 in 3 respondents that we asked said that they do not have access to the information they require to make data-driven decisions. And when we dug into that a little bit further, one of the key issues that they had was access to historical data. So having historical data in a format that is usable and accessible. And the last one is probably no surprise, and we'll have heard through the last day and a half from some of the talks and some of the booths that we have outside. There's a number of exciting technologies coming down the line in terms of AI, machine learning, opportunities for data science. Majority of our respondents said that they plan to use those technologies, but without quality, reliable data as an input, these technologies do not work. Now, the idea is good in theory, but the theory goes beyond that and has been proved in many cases. So there's a number of studies and a number of authors out there that have talked to the estimates in terms of the amount of private sector activity that arises from every $1 spent in pre-competitive data, ranging from $2.50 to $10. And those early exploration activities result in in-ground discoveries ranging from $100 to $150. So just to kind of underline that one again, for every $1 spent, studies show that you generate $100 to $150 back into the economy. This example here is from Australia. So Deloitte were engaged by Geoscience Australia to estimate the economic contribution of pre-competitive data and analysis in the year 2021 to 22. Across the value chain, pre-competitive geoscience data contributed $76 billion worth of value added into the Australian economy, which that year was roughly 3.5% of their GDP. The pre-competitive data was also shown to be used by over 80% of the exploration and mining companies working in the market at the time. And I think the first number there as well kind of stood out to me, that the actual generation of new pre-competitive data was a net positive, adding $71 million into the economy for everything that they invested into that pre-competitive data through salaries and other equipment purchases. As another example, this one here from Canada this time, in 2020, Ernst & Young conducted a study on federal mineral geoscience programs. They found that over the past decade, spending related to geoscience programs has yielded economic benefits of $7.30 for every $1 invested into the programs. And really these results start to demonstrate the immediate support of pre-competitive data has long-term economic gains. And the other thing you can start to see on these graphs is it's not just directly into the mining industry and the exploration industry. The benefits of available pre-competitive data go much wider in the economy. And with, again, some of the talks you've probably been to around the importance of ESG in the market currently, having high-quality pre-competitive data available can be used in conjunction with environmental studies to look at where potential lies and to help with communication around where potential mineralization sits and the impacts on that to the environment. And obviously further downstream from that is then that communication with communities and the public. And when you go searching for new data, you can't miss the importance of the historical data. And in Kazakhstan, there is a massive wealth of information contained within historical records. How to extract that and how to extract that value is a key process. And scans and PDFs aren't enough to really get the value out that the data, or the potential of the data contains. So there's a number of different principles and there's a number of different frameworks you can follow. The example I put up here on the board is a fairly straightforward one that I like to use called FAIR. So it's a data framework. And when considering what you need to do with historical data, it talks to 4 key areas. So data needs to be findable. That means it needs to be easy to locate by both computer and human. It needs to contain the relevant metadata, and it needs to have some form of standard identifier that allows it to be searchable. Now, once it's found, it also needs to be accessible. So this needs to be some easy way for people to gain access to data, whether it's through a platform or a single portal. That means that they can have access to anything that they need without having to go through any rigorous searches or discoveries. Beyond that, the data needs to be interoperable, and this is kind of a key one, and why PDFs and JPEGs don't work when you're scanning historical documents. Data needs to be used and needs to be in a format that is understood and can be used by different systems. So this allows that data to be integrated across multiple platforms, which enhances the collaboration between different industries and different markets, and that, again, starts to promote for the new discoveries. And lastly, data needs to be reusable. So data should be well documented, have clear provenance, and also is shared under terms that enable reuse. So to bring an example, this is some work we did with the Botswana Geological Survey in terms of taking a lot of their historical data and following those kind of principles in terms of making data available and accessible and taking it in a format that can then be used beyond the original systems. So data is quite simple. At the base layer, you need to have the data types. So this is your raw data, which is then taken up into the information layer. So this is where the applications, again, a number of the exhibitors we have here will have applications that you can use to do the interpretation. But key for pre-competitive is to have that top layer there, is something that is easy accessible, allows ideally spatial search, and can make sure that the information is made available to all. So kind of only got a couple of minutes, so I'm going to try and go through these quickly. A really good example here of where pre-competitive data, we've talked about government's role, we've talked about the benefits to industry, but in this case it's where research also has benefits. So this was a study done in Australia again, where they were able to use a wide range of different data types that they were able to locate. So things such as seismic, gravity, magnetic surveys. Now on their own, each one of those surveys provided a wealth of information. But when able to be brought together into a single platform and used for further analysis, it provided a lot more information to them. So in this case, one of the key findings of the study they did was that 85% of global sediment-hosted deposits can be found along the edges of thick tectonic plates. From this, they were able to generate target maps, and these are the kind of things that have been used then by industry coming into the market to help them rank and prioritize their projects to, again, make sure that the investment that they're putting in has the greatest chance of success. And for those familiar with places like Olympic Dam, which is a huge tier 1 deposit, that was discovered off the basis of pre-competitive data. So to wrap this up, so we've talked about a number of the benefits. When it comes to industry, really, it then is where it all starts to come together. So the environment that having good high-quality data creates for explorers and operators ensures that the risk for private companies is reduced, allowing more targeted resource exploration expenditure and helping to ultimately lower costs. So this, in turn, attracts greater investment into exploration within the market, and the initial success that you'll see from those early movers will encourage the fast followers to come into the market as well. So to summarize, we've seen how subsurface data can provide a powerful tool to resource exploration and development. Discussed how subsurface data can help you to foster trust and collaboration between governments, industry partners, communities and research, and it provides a transparent and reliable information on the potential and impact of your resource projects. Subsurface data can drive investment and innovation by enabling more efficient and effective exploration strategies, reducing costs and risks, and creating opportunities of value creation within the market. And subsurface data can unlock value for all stakeholders by facilitating the discovery and the development of those resources, enhancing environmental and social outcomes, and supporting long-term economic growth and development. And the sign's up. So thank you very much.
Yeah.
So I hope there's some interest in it.
Thank you, James, for your good time management. I did see one slide. You had a word fair, but I didn't see the last letter, and I thought it was a fail. it's funny, but I didn't say the last letter. Could you explain and could you say a couple of words about problems, main problems which we can face phase 2 during implementation of your system or your data management system? What the main issues can be during implementation?
So the main challenge is that, as I said, the main challenge is how do you take data that's contained within paper documents, reports, and how do you extract that into that initial layer? So that data layer is critical to get right, because without the data being in a format that, as I was saying, is usable, so the interoperable piece, it can't be used with any other systems. It can be read, but it can't be ingested into anything. So the key task with any of this is how do you take that historical data and initially bring it into a format that can then be used in further technologies.
Okay.
James, thank you for the presentation. We are international based. We have several servers in Africa and Europe, but our headquarters are in Moscow, outstated in Moscow. So is there an option can we use Segment? What do you think?
In terms of sanctions and that kind of stuff?
Somehow.
Yeah, probably not the easiest one to comment on in terms of a data management presentation, but happy to have a talk with you.
You can discuss after the session. Okay, thank you, James, for your time. Thank you.
Okay, thank you very much.
Следующий выступающий у нас Евгений Юрьевич Ермолин, генеральный директор.
Next we have Evgeny Yermolin and James Service. And he is going to talk about the specific topic, so we invite him. So for 12 years I am the head of the service geological company, and today I would like to present you the work of GM service. And we united and combined methods, and we were able to find some hidden ore bodies. As the time is limited in my report, I will just give examples of epithermal deposits. Well, first of all, to start the or deposit industrial way, we need to understand the model. Right now, the epithermal deposit looks like this. We have the source of fluid, we have this acidic medium composition, and we need to have the specific fluids, and there is specific distance from the source, and we need to have the hard rock block. And so here in hard rock block, we can see the formation of epithermal fluids. And there are three different objects like LS epithermal deposit, LS with low sulfidization, and H, which is high sulfidization, and IS, where we have the intermediate level of sulfidization. The most difficult one is LS and IS epithermal deposits, and we are going to speak about them. And in the first part of my report, I will speak about LS epithermal objects. So I will speak about the group of deposits. In 2013, one subsoil users addressed to us, and the first task that we needed to do is to find the continuation of the ore vein with the thickness of 3 meters, that is at the depth of 120-150 meters. So it's like, you know, the layered pipe made of lavas and other different substances and rocks. And this is like the screen for all of the methods. And, you know, to try to find such vein, it looks like the big adventure for any geological specialist and for any geological method. But after we've been working with different methods, we've decided to do it.
We've used the zoning or the in combination with the magnet and the vibration survey method. We used the classical, the conventional method, plus the vertical magnet field, which really increased the method resolution. This vein was located around the so-called isolator. It shifts to the east. In other words, half a year into it, we drilled into it. Half a year later, we drilled into it, into this vein, and it runs across, it cuts across this deposit, the so-called isolator area. We published a number of publications. We've seen a number of publications on this site. A number of geophysical surveys have been run on it, and it was used as a basis. And they crafted a geological model and just issued several publications. It was definitely a success. And the client, as a result, the client did believe in these methods, and he started running his own program of exploring this area by geophysical methods. It was a couple of years ago. By 2019, we saw the emergence of of a survey network, and we found out that the deposit was framed by the edgesites and gravel and the gravel edgesites and rhyolites. This structure is clearly seen on this screen, which cuts across the gravel structure. Here we see the horizons and the dumps. In 2015, the soil and subsoil user paid attention to what was located 150 meters away from the deposit. There are lots of mines, lots of wells, and they revisited it. They ran some detailed magnet photography, and they spotted magnet field oscillations, and as a result, they identified another productivity zone. Then they also spotted something to the northward of the main deposit, and the main border of the gravity field gradient. There is an area which has a 60-degree slant. So it's a blind ore, but it's super. There is another structural level that cuts across it and kind of blocks it, and so there is a level. There is a level of gravel, yes, and it deflects all magnetic fields and our attempts. So we found out that there was a possibility for us to find the rift zone, the rift structure, and there was an increased resistance area at the bottom. By 2019, they already drilled a so-called a portal, and we started extracting ore and taking it to the processing plant. Yes, did start taking the ore to the processing plant. Due to method integration, we managed to discover 4 extra sites using method integration in a matter of 4 years. There was a huge team of geochemists, third-party experts, and drillers who were at work. In geophysics, it's a very challenging site. But when we integrate our methods, when we just tap into different methods and use them at the same time, when there is a semblance of using too many technologies and too many methods, and it's redundant, we should go ahead go ahead with it. So the average step was 40 meters, which was unparalleled. The next thing, I'm talking to a discovery which was only made thanks to geophysical surveys and methods. We were approached by a client. That client had very low budget for exploration. That vein was several hundred square meters, and in cross section there is a zone or an area of intrusions, of superimpositions with around 5 meter veins, high aurum, gold content, and there are also some loose. There is some loose rock, and it was at a distance of about 150 meters. Those were blind veins, very hard to identify. So we were given a go-ahead, like we were given full leeway just to utilize whatever technologies, but we were they said, but we only have limited budget. And there is the area you should explore, but the money is tight, kind of. What we did, was to split the work into 2 stages. We thought that the difference in the magnetic perceptiveness of the ores would enable us to identify something. So what we do, we put in place the magnet field exploration. We use magnet field exploration. It was due to high resolution. We identified some things, but the other method, we used some methods, and here we can see the results. This superimposition area is joined by an area with low magnetic field like indicators. So we ran a complex analysis, including, and we just identified 9 areas of research. And we also utilized an algorithm for image identification on the basis of neural networks. And we identified these zones, which are areas which are invisible at first sight, kind of at first sight. Then in summer we went there and we ran a magnetic profile, and we found out that there is a zone featuring high polarity and high resistance, magnetic resistance. There's only money. The clients only had money for 1 well, and we just did a very good job, So all of our works and all of our activities have one thing in common. There is no technical assignment. We work together with the geologists and the clients to really to write the technical assignment. And this helped us do our work. And in all of the instances, we developed a geophysical model, which it was not just running works, doing work under some technical assignment, but this geological model gave us a very good idea of what to do. We position ourselves as a company that has technologies like geological mapping, other techniques and methods. AGT systems were available of AGT systems booth or radar systems. Thank you. Thank you. Thank you. I have a couple of remarks. We are parts of the international drilling group. Every time we meet regularly, we talk about industry-related risks. And one of the systemic risks, is like this. We can introduce the geophysical survey technologies for deposits, for wells, and there may be some risk-related issues. We, as drilling companies, to what extent should we fear the reduced volumes, a drop in volumes because of the need to utilize these methods extensively? Answer. It will be more and more difficult to discover new fields and new deposits. Of course, there might be some cost optimization. The overall costs will continue growing. With new deposits, you may find it easier to identify, to discover such blocked, screened areas. So the volumes are to drop, but the overall number of wells, will have to do the drilling holes. Will have to run work on. Is going to increase. Am I right? The answer is yes. The next statement, Mr. Dmitry Kolesnichenko, PRAT automation. Ways of increasing the granulometric content of the blast or of blasted rock. I only have a time slot of 15 minutes. We are headquartered in the Russian city of Novosibirsk. We develop software products for higher mining productivity of mining companies. Why granulometric? The granulometric composition of rock isn't high quality. One of the reasons is lack of opportunity to run high quality blasting and survey. The drilling plans are not developed to the standard. Hence, problems with the navigation. Hence, weather conditions. Lack of qualified personnel, lack of control over third-party contractors that do both drilling and filling, the well filling, and a huge amount of paperwork. How do we address these issues in the mining industry without utilizing digital technologies? We set out the different markers like rags, pieces of cloth, pegs. We run specialized solutions like AutoCAD, GSIM. We purchase extra hardware to do extra mining work. Sometimes clients may say we will need extra drilling volumes. What do? We buy an extra some extra drilling equipment, paperwork. Again, by introducing all of this, we try to do this. We charge the wells before charging, using ropes, using tapes, also the human factor, and again doing paperwork. Losses, the financial losses, the decreased volumes, more costs on secondary fracture. Haulers in trucks are underloaded or overloaded, and the overall costs for the mining companies. There is a general rule of thumb. When the produce, we keep track of the products in a cross-cutting manner. The higher the quality of the frac job, of the mining, of the blasting, the higher is the high quality, the loading work and processing. Ways of increasing quality, blasting automation, charging automation, the complex GS solutions, and ways of techniques of tracking the granulate quality. We run the blast management and the systems. All of these systems help us keep track of the quality of work of our personnel and equipment. Drilling related problems. Time. We need too much time for charging, for marking, challenging weather conditions, and the wrong idea people have of the drilling, of the charging, of the blasting works. how can we address it? The top level of software. Speaking of software, we're introducing our solutions. Operators, even a poorly qualified operator, he or she can use it well, and thanks to the high precision navigation system, navigation is faster. And besides, we take into account the various heights and the height gaps. For example, the ore is not prepared, or boulders are not prepared. For example, we have to drill down 15 minutes down. So we do the blasting, and the lower horizon, as a result, may become uneven. We use high quality navigation, and this, by doing so, we do remove this problem. So the operators should monitor the drilling parameters. We take into account the geometry, the unevennesses, and scanner control. Remarkably, there is one important point. By keeping track the sensors that we install additionally, we can also receive the telemetry readings, hence a better idea of how many markers and how many charges per well we need. Well, there is an enhanced opportunity to keep track of the usability of drilling equipment. And again, hence we could cut a total cost of 912,100. So better control of blind spots, better control of equipment, better control, overall. The whole complex is controlled from the top level. Here we can see the overall amount of work performed by one piece of drilling equipment. We can see it by the telemetry, by other data. Raw telemetry readings enable us to calculate the energy efficiency, the energy intensity, and the amount of explosives we need. Reporting. There is the so-called a report generator. It's not part of the software, and you can generate any report can use it to generate any report without any special preconditions. There is software like Micromine, SoftStation, Genius, BlastMaker, and other types of software. I would just like to show it on our slide. There is the third picture to the left. We can see a cross-sector of that well, and we can calculate the energy intensity. We can say that if in the past the robustness of the blocks was like 10 points, but here we can identify that the robustness, or whatever you call it, is 5 items of 5 points. By saying the sturdiness of the rock, we can better prepare for frac job, for blasting. Blasting issues. There is no online information. Previously, for contractors, there are issues with the identification of boulders, or a blasting machine operator finds it difficult, which well requires how much explosives, but especially when it's rain or snow. Charging errors or mistakes, wells are over or undercharged. Sometimes they are skipped. But as a result, there is lack of control over the remaining remaining explosive, lack of good organization in paperwork. Thanks to our software, you can increase the blast quality, skimp on blast, on explosives, use fewer explosives. System components it's the software complex that runs on the blasting machine. There's also a set a blaster set, and there is the top layer design system. So you design a blast or charges online, then the blaster controls the quality of blasting. Well, this personal set of blaster set, they help blasters control the depth, the amount of explosives. You know, when you arrive with your blasting machine to a particular well, you have all of the information about this well. You know, the system displays all information on productivity, the economic benefits or the economic performance. Fuel benefits 1 to 4% less drop in explosives. According to our data, you can free up to 4 million rubles a month on blasting. You use less emulsions, you use less explosives, less manual work. And all of these software products can run independently within one company. But if they work together within one company, hence you'll have the economic benefits and a spike in production. This slide displays the software products we present and we have developed. There are over 7 products, including using robots. Thank you. I hope I haven't gone beyond my time slot. Thank you.
Yes, it's a very interesting topic. Our group has also is also doing the blasting works, and I looked at this and I already started to imagine where we could apply it. We do have some of such things, but you know there are some problems as well. You know, not always customer is ready to pay for this because especially if, for example, they do the blasting and the other people would do the drilling, and I start saying, let us do the positioning of the or location of the vehicle and some other software, but they don't want to pay additionally for this. Then I have a question about infrastructure. Many of the projects that have been implemented or that have been using your systems, they're usually in these accessible areas. But in places where there is no problems with the network or communication. But mainly we work in such areas as Yakutia, Chukotka, and these are really remote areas. So could you tell us what is the requirements to the infrastructure? How much it would cost so that these systems would work? Thank you for your question. Let me start from the final question. Our technology can work in different network systems, GSM, Wi-Fi, including radio channels. We have some polymetal mines in Nezhdaninsk area. There is no network communication at all. And we use radio channels so that to submit all this data. And, you know, if we speak about Kazakhstan market, I'm not going now to speak about Kazakhstan, Russian market. I mean, on the territory of Kazakhstan, we could use the same like satellite system by Elon Musk. But you know, we have the problem. Not always such system by Elon Musk works. It depends on weather conditions. And when, for example, the satellite communication disappears, now I'm speaking about Russian context, when there is no satellite communication, you do not see any results. And this story is quite popular. You can use radio channels to send, you know, you could use USB, you could use and you have data processing of all local mines, right? You do it locally, not remotely, not somewhere at servers. As subsoil users, they are usually large companies and they are really worrying about their critical infrastructure. There is no opportunity to place it somewhere in cloud solutions. Then, how to tell to the customers that they shall use this technology, let's say, how to persuade them. Well, here I cannot even actually recommend anything, but maybe after this session we can talk to each other and I will tell you how some large companies in Russia work there, and they do lots of work on these blasting techniques and blasting works. Thank you. Thank you so much. Okay, next speaker. So we are going to speak to hear Data Plus International, Valery Fomin. Hello, dear audience. Today I'm going to speak about GIS for geological exploration, drilling and blasting operations. So I would like to share our experience on how to use GIS so that to work in this industry. Briefly, we have been working with S3 products, ArcGIS, ArcGIS. If you don't know, S3 is the leading producer of GIS systems all over the world, and the systems have been used quite widely. And in Kazakhstan, this has already, not only in Kazakhstan, but in Central Asia, these systems have already been in use for many years. Data Plus International Company, we are the official distributor of S3 company, and we work on the territory of Central Asia and in Caucasian countries. So today lots of users have already been applying our products, and here you see those companies that have been using our products. If you are interested in this, I can say that we can have the information exchange between the regulator and the company, and it's quite simple. Now let us speak about the topic of the presentation. Today I will tell you about practical experience. So, well, actually we have three logical parts in our presentation. So first of all, I will tell you what is GIS, what is ArcGIS, how to apply it in practice, and then what is the future potential for ArcGIS, so that to use it further. So first of all, ArcGIS, it's not like, desktop or web application. This is a platform. I want to say this is a platform. And it means it is at the same time the web application, mobile clients, and mobile application. It's a desktop GIS to work at the desk, and a GIS portal. I will mainly be focusing on this portal. And we also have different tools for the developers. So this is a set of technologies that are interconnected. You will not have to integrate anything. So it is also important to say that data types are very broad, and I can say that GIS and ArcGIS can work with virtually all data types. And for those users who bought ArcGIS, I want to tell very important information. So the company provides data for free, and maybe you don't have the digitalization, but you can start very fast. You see on each of my slides there is a link, and later you can use this link and to find the information in more details. So what is the most important for ArcGIS is that we have this specific geoportal. And this is a unified place where the spatial data is being stored. I mean, if you have any spatial data, you can keep them there. This is like repository. So if geologists start to do something, they can have the data to this spatial data. I mean, any department could use it together. And if there is information that state bodies have, this information, these databases, state databases, could also be uploaded here. Databases on the maps, on the land plots, and so on the roads. Now let us move to the practical application. So how we can how we can use this web application, how people will use it. So first of all, you can use this web application, and the main specialist in geology will see everything here. So here you can see the list of layers, how all of this could be organized. Here, top right thing, here you can see these special objects. So these are some 2D measurement, 3D measurement, and some other things. So everybody could see everything in this one specific place and receive all the information. And what else could be done? And usually we don't see it. Here we also can have archive data for 15, for 10 previous years. So if you have some previous research, all this information could be uploaded here as well. And so when you choose the object, you could also go to some archive data and receive some reports. Here you can see the specific example from our project. So the main geologist could go to the folder with some data on the wells, and then the main geologist could make some specific solution after analyzing this data. Next thing is that let us speak about the functions. It is very important that all data could be stored in 3D. So what we have here, we have different volumes, voxels, sections, block diagrams, and everything is here. And not only GIS specialists will have access to it, it will be accessible to anyone, to any specialist who needs to use it. So this process is very easy. This is a slide, and I will get back to this slide later. Here we are speaking about empirical bias kriging. And you know, it is very difficult to do the study of the rocks, especially if we speak about assessment or evaluation, what is underground, what is the depth of this location. So that's why we do geostatistical analysis of sample data, and then we do some specific interpolation, or we use some specific kriging, and we can find all those reserves that could be on the surface and underground. And again, here you can see some links to YouTube. You can find all the information there. Here we can do the sections analysis. And again, all of this is available to those people who needs to work. So not only GIS specialists, but to all other. So, for example, here we speak about the assessment of impact of the blasting work. So here we can analyze the channels, and we have some images from drones or from satellite. We can analyze the concentration of some specific reserves. We accumulate all of the data, and then we can do the assessment or evaluation of some specific trends that might happen at the specific territory. For example, how blasting works would impact the environment, how will it be the pollution later, and pollution to the area, or pollution to the nearest settlement, and so on. So we have the specific tools that provide systematic and consistent analysis. The other example is stationing. Some people don't like using maps, but they like to use schemes. So we can use such a specific thing so that to locate some specific objects at some specific territories along the roads, highways, and so on. UAVs. Right now, UAVs, you know, before we had some issues with the slopes, with the recognition of some objects or facilities that are located at some territories. But it was before. Right now, UAV could be used daily, and we can take images, and then we can upload them, and it could be automated analysis of all these images. Speaking about field work, we can plan the field work, and those specialists who are working on the field can use their mobile devices, and they can collect the data on the field site. I can give you an example. Eurasia Polymetal, they have improved their work. They have optimized their field work using our solutions. And so here you can see before how they planned to do it. So again, they did the cross-cutting analysis using the data of this territory. Also, it is needed to say that when we speak about GIS, we speak not only about surface or underground works. Here we also speak about some electronic work permits. I mean, we can make this process automated. You can connect these different parameters like the height or the altitude of the facility and so on. We also can use it so that to make the route with less cost. So we can use it to build the optimal route. So, for example, you might build the road that would be less costly. Then we can also use it when we speak about the placing of drilling rigs. Yes, for example, we need to do the work in 3 places, and we think how to optimize it. So, and I mean, we study the territory, and then we analyze data and understand how to do it. So we also can use our GIS so that to identify some other specialists. So we're speaking about great future. We also speak about machine learning. And here you can see a simple example. Using machine learning, we've identified where we need to have the shafts, and then later we can find some other anomalies using the same system. And with this, I'm going to finish my presentation, and I suggest us to meet if you have any details and discuss it later. Thank you. Thank you so much. Can we ask you a question? Oh, maybe we have a question from our audience. Any questions? No? Okay, thank you so much, Sam. Okay, our next report, we want to invite Ms. Irina Savinova. So she is going to talk about analysis of the effectiveness of stage exploration, geological and geophysical works in the discovery of new gold deposits. Good day, dear colleagues. In our report, we will try to show the role and place of airborne geophysical research in the overall complex of geological and geophysical work based on many years of experience in using our technology, which is called Equator. Modern airborne geophysical complexes usually contain channels, electrical prospecting, magnetometry, and gamma spectrometry. And the main difference between aerial complexes is the design and measurement principles of the electric prospecting systems. The most popular nowadays are active airborne electrical prospecting systems. These include low power frequency systems that differentiate insulators well and that have high resolution in the upper part of the section. And there are also temporary systems that have work well at the greater depths, and when we do the search for some objects. Nowadays, the most modern and the most advanced system are combined systems because they combine the advantages of frequency and the other systems. Equator Aerial Geophysical Complex is the combined system, the combined system of electromagnetic measurement, and therefore they combine the advantages of this and that system, and they work in the upper part of the system and in some other part. So the abilities of the equator technology, we have a high efficiency, the productivity 10,000 kilometers per month, high precision, we can do the work up to, in the scale 1 to 5,000. The tasks that we want to resolve, we need to study some specific magnetic characteristic of the environment and radiometric characteristic of the environment. The key difference of equator complex is its electric search channel. The primary system of equator system provides the impulse that would be added with some additional high frequency harmonics. The spectrum do not intersect with the primary spectrum. And this slide shows the example of the work. You see the high cross-section is the frequency system that shows the detailed part. And then we have some other temporary systems that work. They show better results at more depths. And now let us consider the geological construction of the studied area. This is the southwest of the Russian Republic Sakha-Yakutia, and at this territory, at the moment of study, there were some deposits like Taberna and Gross.
They are controlling rocks here, where metathematically changed reddish sandstones, and it's late uranium, which coincides with the early activation of the dome sheet. The ore controlling structures in this case are the regional zones of faults, submeridional, Token, and subkondensky. It was identified that the rocks with high concentration of potassium are ore-bearing. By form, they represent dikes of the major composition, dikes of the major structure. After detection of Taberna deposit, Taberna Gross deposit, we made an attempt to identify similar analogous objects in other areas. By the order of the company Norgold in 2019, to the west of the detected deposit area, prospective works were carried out with complex equator, the scale 20,000, area 750 kilometers. The company Norgold adopted the phases for the works to be carried out. We followed this schedule for this given territory. The geophysical works at this phase were carried out at 0 phase, which contained a selection of works search for the area, which included magnetic spectrum, gamma electrospectrum. This area survey was advanced in identification of the prospective areas and for the detailed study. On this phase of the work, we carried out aerial works on anomalous sites, chemistry, geological routing, surface geology, and the next stage is the discovery, and the last stage is outlining or objects drilled in plan and in-depth assessment of the source of potential or bodies, and the results of aerophysical works are represented in the maps, in the format of maps. The scale of surveys or imaging enabled to define the or perspective objects, but we need further to have detailed field works, but at the stage of geophysical prospecting. In red, we show the perspective area based with the anomaly with the etalon objects. We see high concentration of potassium, and on this side, so assessment and measurement works were carried out, in the result of which in the year 2023, Raman deposit was detected, and 170 tons of gold were registered. Based on this analogy with the etalon sites of Gross Taberna, this is the deposit Raman and Chuastach, and the section to the right side is the Raman site. On the analogy with the standard objects, we define the prospective areas to the west of the Raman Chuastach deposit, where we carried out assessment and measurement works, and we identified two new or deposits with gold outcrops. Our geophysical works in the big areas were carried out for 1.5 months. If we take the period of mobilization, demobilization into account also. Given these obtained standard objects, we were able to carry it out with Equator to carry out the discovery works and to identify perspective areas, which to make 5% of the whole total under prospecting. And also I want to talk about one more object of Gold. It is Bakhtarnan complex, which is also to the west. The prospects of gold bearing are related to the contrast magnetic anomalies and the anomalies of low resistance in carbonate rocks. And on the basis of this data, we were able to identify the perspective areas. Let's consider some of them. A linear magnetic anomaly in the field is represented by the dikes of the major structure close to the surface. On the dike, you can see the gold crops, and between two these magnetic anomalies, we identify the conducer of the isometric form, the presence of which can be correlated to the karst formation processes and the active sulfidization. The discovered local anomaly maybe is related to the content of the core-bearing anomalies as Koronavsky and Karolinsky types of objects. And one more site here where we don't have any magnetic anomalies, radiometric anomalies, but we can also see the low object and the existing gold bearings and points of mineralization, and with Karling-Kurganowski type, maybe we do have here perspective gold bearing objects. What are the major conclusions? Let me say, and I want to say that while looking for the deposit of useful resources, we need to use the whole complex of geophysical surveys, and not excluding error, geophysical surveys, which enable us to cut the costs of such surveys and to increase the tempo of prospecting. Thank you. I have a question. When IRGH was used, the major part of the money was spent on helicopters. In order to carry out geophysical surveys, we rented the choppers. What means do you use to carry out such kind of work? Do you use drones or helicopters? No, in our company we use mainly helicopters. Why? Because equipment is very heavy. Why don't you use drones? How many kilograms of equipment do you have to transport? Or do you use your own small chopper? No, we don't use our chopper. The weight of the contemporary era geophysical prospecting is 100 kilometers, but critically important matter is energy which we consume. We consume around 3 kilowatts, but contemporary drones cannot provide this electrical power. So it means you spent the whole amount of the money on chopper support. Yes, maybe 1/3 or even half of the money spent on choppers. Thank you. The next speaker, Alexander Nikolaevich Oshkin, General Director of LLP Polsk. It's also interesting, very good. Thank you. The topic of the topic in the screen, seismics on solid useful resources are used as rare, maybe in some rare cases, but unique cases. But there are so many reasons for it. But yet, one of the most important problems is the cost, of course, and conditions under which seismic prospecting can work. But when the seismics is functional, at the outcome we get a quite detailed results. But the specificity of it is that it ensures high precision, which represents geometry of ore bodies, layers, ore bodies, and other things, and faults, of course. From the point of the faults, it can be also, maybe it's not related to solid resources, but it is related to development. Seismics is used widely in oil industry and for porting of seismics to the solid rocks. It's better not to use a bug, but it's better to use the technologies which have been developed, but modifying them. What is the difference between the seismics or between the carbons and solid resources? It's scope requirements to the equipment, it's the density of observations, but most likely that the equipment which exists in the market for seismic prospecting, it can be used easily for solid mineral resources. For solids, and in the future we can get quite excellent results. But I want to show several examples of the international sources from open source and from our experience, so that you will have understanding in which form these seismic results are issued. This is an example of South Africa exploration on platinum. The interval is 350 meters. The area is shown. It's 5 to 4 kilometers. The major task is structural building. This is geometry of the geological bodies. This is an example of two perpendicular sections of the seismic cube, which you can see here, and images of the environment and borders in the right side of both sections. You can see the fault like a stepwise form, and this is an example on the right. It's a voluminous structural model of the deposit, which we got it. It's interpreted with identified geological bodies. On the left side, we show the map of amplitudes by horizon, UG2 with visualization on it of the geological objects. You can see the major fault like a diagonal line, and you can see that this is the fault of where it most likely looks like a graben, and it's not obvious, but in the form of sports, you can see dikes, which are indicated on the right side with vertical elements, and how they are represented in seismic exploration. This is an example of visualization. In Spain, starting from 70 years, when we explored for potassium bodies, we used to do these seismics with a few channels, but now they already passed over to 3D seismics and more detailed results. What is the matter? The soils quite often have so complex forms, and you can see it quite well in the central area. You can see folds. These are soil diapers, and when you see in front of your eyes such a visualization of the geological object, which is your target, you can carry out modeling, development with better efficiencies to minimize risky situations. In Russia, seismics for solids, it has been used for long by the company Elros, which starting from 80s introduced 2D seismics in the form of the method, or one of the methods in the comprehensive program of geological works. But starting from 2011, they test 3D seismic exploration to find kimberlite pipes. And this is an example from open sources also. And it's a representation of these pipes in the seismic cross-section. The pipes are overlaid by heterogeneous sedimentations with the thickness of several meters, and the decisive role is played by aero and electrical magnetic surveys. But Elros focus on seismic exploration because they have traps which are widely spread on top, which close the kimberlite pipes and don't give a chance to work using the aero methodology. Magnetic exploration doesn't show anything, display anything through pipes. We have some experience in this area of seismic exploration, which we can use for solids, but for intervals of hundreds of kilometers. We have a series of light seismic sources which can be moved using a small truck, and when we use such sources on such equipment, we can get these kind of results. This is about Kazakhstan, or one of the coal deposits. The task is to identify the faults while producing coal, excavation of coal. On the left image, we show how these faults are identified. On the right side, interpretation. This is a Russian example, testing of the technology. We worked on the longitudinal and cross-sectional waves up to the depth of 1.5 kilometers by the vertical scale. The major elements are 500 meters. The image is being built up, and we didn't have any geological ops. It's just for testing of the field technology. But anyway, we have the image of the environment, which is quite detailed. When you work with a complex bodies, such as faults and some ore bodies, 2D seismic quite conventional results, because reflection comes from different sides, not from below, but if it's a subvertical bodies, and it's impossible using 2D seismics to visualize something and to see where the reflection comes from. For such purposes, 3D seismic will be the appropriate one. And this is an example of our works carried out in Kazakhstan. On the left, on the photo from the drone, with transmit the source on the right equipment. It's without cables, which can be disseminated on any area quite easily. And we compare here 2D and 3D profile on the left map. We show how they are mutually located, and their visualization 3D more detailed, more number of faults can be identified in 3D versus 2D. For such tasks, it's better to use 3D seismics. But our biggest experiment for this moment are the works which we carried out in Norilsk this winter. These are experimental works, and the task was to see the intrusive body with the basalt. The thickness of basalt is more than 1 kilometer. Intrusive bodies are in them. We used 2 impulse sources, a group of them transported by heavy tractor, and cableless system GXX for each canal. For each canal, we have an autonomous seismic station, which is not related with others. On the left, we show the system of observation. Blue points of exception, points 20 steps between the channels, red excitation points. And now we develop and introduce the technology of seismic survey, but in movement, in motion, because it enables us quickly, effectively to carry out excitation. The sources are tracked by the tractor. Each 5-6 seconds there is a shock, and the step between excitation totals to 5-4 meters. We use quite a good coverage.
And here we see the qualitative results despite the weaknesses of the one-time impact. Plus, we also add here the opportunity to make the points of excitation curve. We register the coordinates, and we allow our impulse group to move or to use a more simple way, so we don't have this strict observation network, and we receive quite good results. So here you can see the photo of those traces from our observations that we've implemented on this project. And here you also can see the data processing examples. Initial data are quite are not so exact, right? Accurate, and then after we increased the quality, and out of these examples, you see this left picture, and here you can see that there are some horizontal dikes, and basalts are located higher this bright border. And here we speak about the depths from 1 kilometer to 1.5 kilometers. Basalts, they are also layered bodies, and it simplifies the work. And here we also have some subvertical boundaries that are connected with intrusive bodies, that are connected with the intrusive body. Different attributes have been used here. The maps or paleo slices that have been used here. It's sub-horizontal cross-sections where we can see this complex form intrusion. And of course, we did the comparison with the data from the well. And here you can see some data on wells, and we see the boundary of this intrusion. And at the bottom, there is a geological model. And finally, we've identified this intrusion, and here I want to speak about tectonics, about the faults, and we can see it quite clear here. On the left picture, there is a coherent map where you can see these faults, and we see that there is a lack of coherence in recordings because one block is quite distance from the other. And this is the way we do it with a wave. So finally, we've identified intrusion, we've identified the boundaries, and we've built the model that includes all the faults, and this is a detailed model. And speaking about some conclusions, the modern seismic can work with some minerals, and there are such cases. And modern approaches allows us to decrease the costs for the seismic exploration, and it could be done very fast, so I mean in decreasing in time. And finally, I would like to thank Nurnickel company, because jointly with them we have done this work, and the company Geospace that supports us with the equipment for conducting this seismic exploration work. Thank you so much. Thank you. We have a question from our audience. Thank you so much, Mr. Alexander. Based on your experience, for 100 meters, for the contrast environment, what minimum layer would you be able to identify? Here the intrusion was of different capacity, and the capacity that we used at the depth of 1 kilometer, we had about 20, 30, 40 meters. This is at the boundary. These are my answers. And as for 100 meters, yeah, for the region Malobotuminsky, I guess that the indicators would be higher, but not as much. Maybe we can expect up to 10 meters, but we need to look at the specificities. Okay, thank you so much for your report. It was really interesting topic. Thank you. Now let us show the survey results. In just a couple of minutes, we see that here in our hall we have people who are dealing with geological exploration and some blasting works. Everywhere we need to have modern technologies. We see 100% yes, nobody answered no here. Next question was about the following. Well, actually mainly voted, and I voted myself, the most efficient, the best effect we will receive when we have different technologies and solutions. Well, actually, we have lots of speakers, and we understand that if we use the set of different technologies and solutions, we will optimize and make our work more efficient. And the final question, the next one. No, well, somebody has already been using some of the method on a permanent basis. As for satellite, everybody is using the satellite, robotized drilling machines, 3D modeling, the well stationing. Well, almost everything in use besides or except 1 point. Okay. Next question. What prevents implementation of new technologies in Kazakhstan with regard to the geological exploration? First of all, high cost, absence of qualified personnel. Well, we see that 100% said that there are no qualified specialists in blasting and geological exploration. Then absence of technologies, almost 80%, and 100% of people considers the reasons that have been mentioned as reasons preventing the use of technologies. and of course absence of the internal customers. Well, our task now is to promote these new technologies and solutions, and we need to show that technologies and solutions are working, and this is important for our future. Thank you. That's it from our side.